And edges again should have IDs starting from 0. Okay. And we should have edge uh, starting point, starting node of the edge and ending node of the edge. So like this one will be um, in the actual diagram it is 1 to 2, but remember the IDs. Okay, so this is for us. We did not use this in setting up the text file. So these are the three columns we used, and therefore these are the IDs we have to use. The starting point is 0, ending point is 1 for this. Okay, and of course the ID is 0 and the distance is 3, right? That one. And then 0 to 2, the ID is 1 and the distance is 2. Okay, and then we have 0 to 3, ID is 2, distance is 5. And then we have this is 1 to 2, okay, ID is 3 and the distance is 3. And then we have 1 to 4, okay, and the distance is 3. Okay, so now we are done with that. We come to this one, so that is 2. Okay, so we've already taken care of these edges. So here you need to go 2 to 3. Okay, and then we have 2 to 4 and 2 to 5, right? 2 to 4 and 2 to 5. These are 5, 6, and 7, and the distances are 2, 5, and 3. Okay, so 2 to 3, 2 to 4, 2 to 5, and then I missed 2 to 6, and the distance is 7 for that. Okay, so that will be edge ID 8. Okay, so now that's done. This one we have these two already done, so 3 to 5. Okay, 3 to 5 distance is 6, ID is 9, and then that's done. So we go here, so these two are done, so we have 4 to 6. And ID is 10 and the distance is 4. Okay, now that's done. So here you have 5. Okay, these two are done, 5 to 7. And 5 to 7 distance is 1. Okay, and then that one, okay, so these two are already done. So 6 to 7 and node ID is 12 and the distance is 2. Okay, so now we have to set up the edge data in the same way. So let me take that and copy it here. Okay, and then make the changes that we need. So here instead of N, we must have E to stand for edge. And then we have the starting point Okay, start should be from here, Q. So we need after E, Q22, and then a space. Okay, and then you have R22, and then the ID S22, and then T22. This is the distance. Okay, now this should be okay. So you have E indicating it is an edge, 0 to 1. Okay, ID is 0, distance is 3. Okay, so now we are ready to copy that. All right, so now we copy all of this, take it to our text editor and paste it here. Okay, so now let's save this, and I'm going to save it as MST minimal spanning tree graph dot text. So save that. Okay, so now we are ready to head over to this site. Okay, test the algorithm. So now choose file and then navigate to the folder and choose that file. Now if you made a mistake and you have to choose a different file, then again, as I said, this site is a little clunky, so you have to click choose file and then you have to cancel to clear. Because once you have no files chosen, that's when you go and choose a different file. So go choose again, take that file. Okay, so now the network is shown here. Okay, so check that against what we have in the file. So okay, so this is what that is. Okay, and then we head on down to run the algorithm. Now you can go step by step by clicking next, or you can do fast forward, and that will find the answer for you. Okay, now the green lines are the ones or the edges that is selected as the optimum. Okay, you can download this as an SVG file, or you can just simply do a screenshot. So you can do snipping tool in Windows. Okay, and then click new. Now highlight that. Okay, so now you copy and paste it here. Okay, and adjust the size. Okay, so now we can describe the solution. So we have, remember it is the green ones, and the edges numbers must be incremented by 1. So this will be 1 to 2. And the distance is 3. Okay, and then 1 to 3. Okay, you start with a single quotation mark, so that way it won't, otherwise this number will go in as a date. So 1 to 3 is 2. Okay, so and then we have 3 to 4. 3 to 4 is 2. Okay, 3 to 4. And then 3 to 6. 3 to 6 is 3. Okay. Then here we have 2 to 5. I should have done that first. 2 to 5 is 3. That's done. Okay, so now um, 3 to 6 is done. Now 6 to 8 is 1. And then 8 to 7 or 7 to 8 doesn't matter. 7 to 8 is 2. So the total distance needed for the minimal spanning tree is 16, which is the same thing that we got by applying the algorithm.